Hello, my name is Chip Shearrow. I'm the lead for the Advanced Manufacturing program at Harrisburg University. It's a new program. Before I get into the program, I'd like to tell you a little bit about myself. I started out at Dublin City Schools in 1982 through 1990. While I was there, I created a technology education program for K-12. That meant everybody from kindergarten through 12th grade was getting the education. The neat thing about that is I took a program that was an industrial arts program that had 42 people in it and brought it up to 119 people going to college. After I finished my PhD, I went to Ohio Northern University, where there I had for 7 years I had an unbeaten robotics team in the United States. Nobody could beat us, Cal State, MIT, nobody could. It was noticed by the military and also by NASA, at which point I was drafted to NASA. So in the year 2000, in June, I went to NASA. While I was at NASA, I built the largest manned spaceflight data system that holds everything that an astronaut touches, whether they're sitting in it, they're riding in it. Even the outhouse for the space station is on that system. The system still stands today and is being used for the new vehicles. When we stopped flying at NASA, I got bored and came north to Harrisburg and started working for TE Connectivity. Spent about 4 years there. I was running their data system, which spread across 3 continents and 3 data systems. The systems also had about 72 servers in it. When they decided to take their IT offshore, at that point in time, I went through and decided that I wanted to go back to my manufacturing roots, and I did a proposal for Harrisburg University. The proposal was accepted by the president and the vice president in about 15 minutes, and that's where it all started. So I took about 2.5 years to put this program together. It has 22 courses, custom courses, and everything's state-of-the-art. It's so important that the university is now investing about $40 million in the program. So you might ask, what is manufacturing? Well, manufacturing is the making of products for sale, and when you use labor and tools and machines, and automation. And right now in the United States, there's over 2.5 million jobs sitting out there ready for people. People used to think that these jobs were dirty, low pay. People worked in sweatshops and they were dead-end jobs. That's not true anymore. These jobs are centered around good paying jobs with good hours and good facilities. Have you seen many robots work in a dirty place? There are several things that manufacturing is not. The first one is it's not a dirty place where you can work. There's a picture on the slide. Yeah, there's another picture on the slide on the bottom right-hand corner that shows people sitting at tables assembling parts. Well, those people don't work there anymore. It's robots. So instead of being a person who assembles something, you're now a person who runs a robot. Now, the big thing that you want to take a look at is the diagram with the circle on it that has the different icons on it. This shows the different areas of study, which are very important to you because these are all the areas that are included in Industry 4.0. They include autonomous robots, system integrations, Internet of Things, or IoT, simulations, additive manufacturing or 3D printing, subtractive manufacturing, cloud computing, augmented reality or virtual reality, both are in there, big data, cybersecurity, and then around that you'll find new processes, compliant robots. Those are robots that you might find that you can work with close and you don't have to worry about being safe around them. The digital twins, which is something new for manufacturing, and then also networking. Those are all items that are included in Industry 4.0. In this program, you will touch every single one of those items. You'll get a chance to hands-on, use it, and once you've used it, you'll make a decision on what you want to do for the rest of your life, at which point you go through and decide on what you're going to do, and you'll have jobs waiting for you. Now, there's 4 manufacturers on that same page. One is Stratasys, they're our 3D printing or additive manufacturing people. There's Mazak Machine Tool, which is our subtractive manufacturing, ABB Robotics, and also PTC. While you're in the program, not only can you graduate with a BS degree in advanced manufacturing, but you can also be certified by 5 different companies on their skill set. Now, most people say, "Hey, how can I work with this stuff? It's complex." Well, it's kind of like eating an elephant. You don't shove the whole thing in your mouth at one time. What you do is you go through and you take a spoon and you eat little pieces of it. So what we do to teach you technology, we teach you little pieces of it, and you add them together, and as you add them together, you finally get the full picture. The real shortage that I just mentioned earlier, by 2025, there's 2.5 million jobs available. And those jobs include many, many different titles. Some of them have engineering after them. Most of them have technologists after it. When you leave the program, you'll be a technologist. You'll understand the technology behind the processes. Some of these new processes coming to the university include laser technologies. We're having a laser cutter come in that's capable of cutting up to a 1/2-inch thick piece of steel. We'll also have what's called a water jet. The water jet is a device that forces water through metal and cuts it clean. We're also working with mainstreaming new processes, which includes friction stir welding. This is a process that was invented down at Johnson Space Center while I was there, and the man that invented it, Dan Rubicki, is the person who is patented with it, and we too can do this technology. It's now being used to put all the space vehicles together, and it's also being used by mainstream manufacturers. If you know this process and can work it, you've got a job. With additive manufacturing is exploding. It is a new area. There are several manufacturers in Ohio that have gone through and pulled their whole production lines out of old factories, and they're putting in large printers large enough to print cars. But you're going to say, I really don't want a plastic car. Well, that's okay, because with printers that will do steel, you can now actually print a body for a car or frame for a car out of the metal. And by the way, we are picking up a 3D stainless steel printer from Stratasys in the next 2 months. The next part of the process is integrating these systems, putting them all together. And if you look at the Shrek movie, and Donkey's talking to Shrek, and they're talking about onions having layers, and ogres have layers. The reason that is there is because all this technology is based on layers. You do one layer at a time, and you move to the next layer. That's how we work. Now, with system integrations, that's the part of putting together robots, automation, and whatever it might be in the production line. That looks complex when you look at the pictures, but it really isn't complex as long as you do it one piece at a time. The next phase that you move into is called digital twins. This is new. This is where you build something in the CAD software, you collect data through IoT, and you put it into the system, and it tells you if the part's going to fail or not. If the part fails, then they take that data and they do a simulation to figure out how to fix the part. Once that part is fixed, then they go back to whatever was broken and replace it. And the picture you're looking at, it's a robot that was told he had a screw loose. That screw being loose, he's trying to fix it himself based on the information coming out of the monitor. This is the same thing they're doing for cars. It's being done today. Now the digital twins, a good example of it is a bicycle. The bicycle was built in PTC software, in the CAD software. They use the IoT to collect the data points off of it. Once they collect the data points off of it, then it goes into the system and is put back out through Vuforia. That software is what's used, as you can see, to view the data. It'll tell you what the sensors are doing, it'll give you the history on the sensors, and provides the information needed even for a service technician. In simulations are going strong. We will simulate anything from parts to work cells to machine tools to factories. The machine tool simulation has been around for quite a while. In fact, I took simulation to Johnson Space Center and started them with it. They were cutting the bulkhead for the X-38 while I was down there. It's one of the projects we worked on. It was a lifeboat for the space station, and they were down to the last 4 hours of cutting after cutting on this piece of aluminum for 4 days, and there was a piece of bad coat in it. And the cutter went off to the side and cut right through the material, and they lost that hunk of material. Because of that, I brought the simulation in, was able to show them that they could have simulated it ahead of time and missed that human error. Unfortunately, they didn't miss it, and they lost the piece. It cost them about $250,000 in seconds. Autonomous robots, they're running through. There's pictures of them being on 4 legs. There's pictures of them being on 2 legs. Now autonomous robots are getting to a point that they look like real humans. We also have compliant robots. These are the robots you can work with that aren't going to hurt you. You can work with them side by side. If they get in your way, you can shove them out of the way. When you're done working, they'll go back to doing what they're doing. IoT, I've mentioned it a couple times, Internet of Things. Anything that you touch that's plugged into a wall, that your phone, your car, your washer and dryer, your furnace, they all send information back to the manufacturer. This information is used to better products and also see how they're being used. Now, IoT is so important that somebody can have an international company and think that there's something wrong with the production line, and from a remote office they can drill down into the different companies, find the company they need, find the production line they need, and then find out what's wrong with that production line. At that point in time, it's somebody like you is the person that's going to go in and figure out what's wrong with the production line, offer up a solution, and then build it out. That's where you're headed. In augmented reality, there's a difference between augmented reality and virtual reality. With augmented reality, what you have is the ability to project your CAD data or written data onto a screen and onto the object where somebody's working. In virtual reality, you're actually physically manipulating the part. There is a difference, but we deal with both of them in our program. We talk about cloud-based technology. A lot of cloud-based technology is based around design and also tracking of parts. You know that when you order something from Amazon, you end up getting 50 million emails. It's been purchased, it's been moved, it's been shipped, it's on its way. That is what the cloud has done for you, and it's done a lot for manufacturing. We can now trace something from beginning of manufacturing all the way through to delivery to the person. Now, our program is much different from most of the programs at Harrisburg University. Most programs bring you in the top side of a funnel and they point you into one major, one particular thing you're going to do. Our major is not like that. You come in the little end of the funnel and we put you out into our program and you get to look at all those different pieces and work with them. When you're done, you will have a chance to decide what you're going to do the rest of your life, or at least for now. And once you've done that, then you'll find that there will be jobs waiting for you. In fact, the truth is that right now there's 60 local jobs and 160 national jobs waiting for students. Now we're moving into a new facility. The university is investing $30 million into the first 3 floors of this new 17-story building downtown Harrisburg. Of that, my program will have 13,000 square feet. We'll service about 260 students with 5 full-time faculty and 6 or 8 different part-time faculty. This is quite an investment. It includes about $1.6 million worth of already donated tools and materials and about $8.9 million worth of new equipment, or I call them toys. We have an advanced manufacturing, robotics and automation area and additive manufacturing area. That area will hold, of course, the robots, automation, pneumatics, hydraulics. It'll also include the additive manufacturing, which is 3D printing. You also have a non-metallic material processing area where we will process woods, plastics, fibers, things like that. Along with this lab, there's a testing area. You will make things to be broken, and you will break them up. You won't take them home. We also have a metallic materials processing area. That's where the big machines go from Mazak, one of our partners, and we have a welding robot in there that can do anything that any robot can do on any production line in the United States. It is state-of-the-art. In there, you'll also be pouring metals, hot metals. We'll be pouring cast iron, which happens to melt about 2,800 degrees, which means that as long as you are working there, you'll have a lot of protection to be worn. There will be a CAD CAM area where you use CAD software. You'll be digitizing items to bring them into the CAD software and a point cloud. You also have an electronics and a PLC area. You also have a SIM area, an FMS area. That particular area is where there's 12 stations. Each student works around each one of the 12 stations. They figure out how to use each robot and each piece of machinery, which includes a mill, a lathe, a laser, automatic storage and retrieval system. And what you do is, towards the end of the semester, you pick a project and you turn on the system and you leave the doors, you go out the doors and you shut off the light. That's called lights out manufacturing. You come back in 4 hours. If the project is done and it's completed its task, because you've set it up that way, you get an A. And if you don't, you work on it again and you get it until it's right, and it can be done. The last area I want to talk about is our nanofabrication area. Not only will you be able to build things you can see and hold in your hands, but you're going to be able to build things that are so small it takes a microscope to see them. This particular facility includes a small learning area, a room where you can put your bunny suit on, as I call them, and then it has a clean room. We already have 4 of the programs at the university that are interested in using this facility, and we've had companies calling looking to rent time. The Friends of Manufacturing. These are people that have already signed up to support the program. From these people, we have already received $1.6 million worth of donations. These are all people that are looking for employees. They are looking for you. So remember, the advanced manufacturing isn't really hard. You got to eat that elephant 1 spoon at a time, and you got to do it in layers.